All right, ladies and gentlemen, today we're going to be talking about electrical work. Before we get into that, I want you guys to look at this problem. So determine the electromotive force at standard conditions for the aluminum zinc electrode if the concentration of zinc ion is 0.3172 molar and the concentration of aluminum ion is 0.1165 molar. Give you the equation there. Make sure we get that balanced up. Work through that, get that done for class. Then we'll jump into electrical work. So what is electrical work? Electrical work is the amount of electrical energy needed to perform a given amount of work for a specific amount of time. So we have the equation work max is equal to our Gibbs free energy, our delta G. So we have the maximum work is equal to negative NFE. So number of moles, Faraday's constant, and the electromotive force there. So we have work exerted is equal to positive NFE exerted. So we remember that our work has units of watts. So those are joules per second, watts, joules per second. And we know that 1 kilowatt is equal to 1 kilowatt hour is equal to 3.6 times 10 to the 6th joules. All right, so we have this problem here. So calculate the amount of energy needed in kilowatt hours to electroplate 1.523 kilograms of copper if 1.873 volts of electricity is applied. So we need to know a few things before we get started. We need to know Faraday's constant, 96,500 coulombs. We know that 1 coulomb volt is equal to joules, 1 joule. And we know that 1 kilowatt hour is equal to 3.6 times 10 to the 6 joules. Now we take a look at our problem here. What are we working with here? So we know our half reaction for copper. Copper 2 plus 2 electrons goes to copper. I can set up our equation. So we know that 1.523 kilograms of copper is what we're given. We want to find that in moles. So we have to convert it to grams first. So 1,000 grams per kilogram. We use our atomic mass from our periodic table, 63.5 grams per mole. Set that in the equation there, 1 mole, so that we can cancel out our units of grams, get moles. Then we have to find for every mole of copper that we produce, we're putting 2 electrons into it. And for every electron, we get 96,500 coulombs based on Faraday's constant. Convert the units, or we use 1.873 volts is how many volts that we're putting in. Now we use our unit conversions, 1 joule per 1 coulomb volt. Plug everything in, so 1.523 times 1,000 times 2 times 96,500 times 1.873 equals divided by 63.5, and we get our answer of 8.670 times 10 to the 6 joules. Now we're not quite there yet because we didn't want our answer in joules, we wanted in kilowatt hours. So we use our conversion here. 1 kilowatt hour is equal to 3.6 times 10 to the 6 joules. So we put our answer over 1. We put our conversion, so we put joules on the bottom, so we get kilowatt hours at the end. Our answer is 2.408 kilowatt hours, and that's our answer. All right, we'll do this problem in class to determine the amount of energy produced in joules for a voltaic cell of silver and potassium if 18.92 grams of silver plates out in 3 hours. So we want to report your answer in watts. And I want you guys to work through these 2 problems with a partner. So write these down, find the amount of energy in kilowatt hours that is needed to plate 1.782 kilograms of aluminum if 6.211 volts is used, and then leave some space. Determine the amount of energy produced in watts in a voltaic cell of copper and lead if 61.08 grams of copper plates out in 67.50 minutes. That's all we have for you today. We'll see you in class. Take care.